Okay, so now we should be recording. So I'll just say a few words. Hello to everyone who will be watching this later. I have with me today Professor Christo Wilson, who has kindly agreed to give a talk in our little workshop. And Professor Wilson, you're working on a great deal of topics, and I will leave the introduction to you. But one thing that I did want to mention and to bring up before we begin is, of course, the work that you do in Northeastern on auditing algorithms. And there's a large scope of this work, right? You're empirically studying what the algorithms are doing from if Google is personalizing its political news to pricing on Amazon to even maps. I was surprised to learn that Google and Bing Maps are actually heavily personalized. And recently you also expanded to YouTube and so on. And there is some fascinating work there and results. And not only it's covered widely in press, but there is public code and data. And with your permission, I will leave a few links in the description, just in case. But with that, thank you again for joining, and the floor is all yours.
Well, thank you very much. And I'm happy to be here. So yeah, I'm Christo Wilson. I'm a computer scientist at Northeastern University. I'm a faculty associate at the Berkman Klein Center for Internet and Society at Harvard. I wear a number of different hats as a researcher, but my primary reason for being here today is my work on algorithm auditing. So what does that mean? This is sort of a nice way of saying that I'd like to reverse engineer big platforms to understand the kind of data they're collecting, the kinds of systems that they've built if they're using machine learning, and ultimately, how do those systems affect our life? Because they're pretty much everywhere now. So I've done a lot of work looking at things like filter bubbles and political misinformation and fake news, historically on things like Google search, and now increasingly on places like YouTube. Another thread of this work concerns bias and discrimination. So I've done a number of studies looking at whether there were gender biases or racial biases on a variety of online hiring platforms. Some of these are kind of gig economy based, like TaskRabbit and Fiverr, but now increasingly we're looking at mainstream hiring services like Monster and Career Builder and Indeed. So then another thread of my work is looking at online markets and marketplaces to understand, again, how different algorithms perform and behave in these areas. We've done studies looking at price personalization on major e-commerce sites. So whether two different people get two different prices for the same product, and if so, why? We've also done a number of studies looking at ride-sharing firms like Uber and Lyft, because they have dynamic pricing algorithms that are very interesting, but also fairly controversial and entirely opaque. So the study I'm going to talk about today was published in 2016, and this was our first time looking at Amazon. So Amazon is, of course, a fascinating target for study because they are hugely important for online commerce. They're arguably the largest online commerce platform for consumers. And Amazon is just a mess of algorithms. We can talk about their different recommender systems. We can talk about their search algorithms. We can talk about how they target advertising. There's just a bunch of stuff that shapes how the platform works. All those topics are fascinating. I would love to study them in the future. But for this study in particular, what we were interested in is dynamic pricing by sellers in Amazon Marketplace. Right, so if you go on Amazon and you look at a particular product, let's say a phone case, right, there's this little link in the bottom right-hand corner that will take you to the list of merchants who are offering this product for sale. Right, so Amazon is a true market in the sense that Amazon themselves sells products on Amazon.com, but it's also a platform for third-party merchants. And Amazon says that as of fairly recently, the third-party merchants actually make up the vast majority of sales on the platform. So the other thing is that Amazon offers APIs for sellers to engage in dynamic pricing if they want to. So there's tools that sellers can use to change their prices in response to the marketplace conditions. And we were really interested in whether sellers were actually engaging in those practices, and if so, what the effect was and what the dynamics looked like. So we started collecting data about third-party merchants and the offers they were making, and we quickly realized that that wasn't sufficient to complete this study. So the other huge covariate here that we have to take into account is the buy box. So when you go and look at a product on Amazon, most people never actually click on that link in the bottom right-hand corner to see the offers from the merchants. Rather, the vast majority of sales on the platform happen through the buy box, which is this box in the upper right-hand corner. Right? That's the one that says add to cart and buy now. So Amazon has an algorithm that decides amongst all the merchants offering a given product, which one of them will be featured in the buy box. Now, this is crucially important for the merchant. Right? When a customer comes and clicks add to cart or buy now, by default, right, that seller who's been selected for the buy box is the one who makes the sale. So sellers are not only competing with each other, they're also competing with this algorithm, the buy box algorithm, for placement in the buy box. Right? If they can secure the buy box, then they can essentially capture all the sales of this product. Now, Amazon has said some vague things about how the buy box works. It supposedly takes price into account and some other factors, but nobody really knows how the buy box algorithm works. So this became the second facet of our study. Right? First, trying to understand how does the buy box work, and then coming back and saying how does that impact or not impact the behavior of merchants, because they're not just competing with each other, they're competing with this algorithm for sales. So the contributions of our study, we, to my knowledge, present one of the first and only comprehensive pictures of merchant dynamics on Amazon Marketplace. This is an area where there's a lot of speculation amongst merchants, how things work. This is one of the first scientific studies to try and tackle this topic. We use statistical tests and machine learning to try and infer how the buy box algorithm works and the features that it takes into account. We developed a kind of a cute technique to try and identify merchants that were engaged in dynamic pricing. And then I'll talk about kind of what the dynamics of those merchants are and what we can learn from observing their behavior. So we'll start by talking about how we collect data. I'll give you some key findings from the study, and then I'll get on my soapbox a little bit and give you some takeaways that I think are important from this work. So with respect to data collection, we did 2 crawls of top selling products on Amazon. One of these was in September 2014, and this included 837 top selling products across a variety of categories. And in this data collection, we got all of the pages of sellers offering each one of these products. We then went back in August 2015, and this was to try and understand the buy box itself. So in August 2015, we crawled 1,000 top selling products, and that crawl included the product page, which includes the buy box, as well as the first 2 pages of sellers offering each of these products. So the reason we focused on the first 2 pages is because we noticed that the sellers who were actually making reasonable offers tended to fall within the first 2 pages. There may be other merchants offering the products, but they tended to have crazy inflated prices, and they're probably just drop shippers. So our crawler was dynamic. For products that we saw there were more price fluctuations, it visited more often. But on average, every one of these products was visited every 25 minutes for about a month. So what is the actual data that we got for each product? Right, so one of the most important things is up here, we got all the social feedback. So the star ratings, the rating count, and the review count for all the products in our sample, as well as the price. We get all the information from the buy box. So which merchant is being featured, the shipping speed that they're offering, whether they're using fulfillment by Amazon, so Amazon's logistics service, and whether the product has Prime eligibility. And then digging into the other offers from the merchants, we got the first 2 pages of these. So this includes all the same variables for all the merchants offering these products. Right? So their offer prices, their shipping speeds, the amount of feedback they have, etc. So based on these data sets, what can we learn about Amazon and what can we learn about dynamic pricing? So we'll start with overall dynamics of the marketplace. So what I'm showing you here on the x-axis is the number of changes in the buy box over time. So the number of times that the occupant changed over the course of our observation window. And the y-axis is a CDF. The red line is the number of times the price in the buy box changed, and the blue line is the number of times that the actual merchant making the offer changed. So the takeaway here is that the marketplace is actually highly dynamic, right? Around 50% of the products had significant dynamics. The buy box price is changing anywhere from 10 to over 1,000 times over the course of a 1-month window. So the marketplace is actually pretty dynamic. There's a lot going on here. So it seems like there are a lot of changes happening in the buy box. The question is why? What is it that the algorithm is taking into account to try and choose merchants? So here, what I'm showing you are a number of different variables that we could see in our data, and then whether they mattered to this buy box algorithm. So the second column is a decision tree model that we trained, so a little bit of machine learning, and I'm showing you the weights that the machine learning model assigns to these features. And then the column on the right is a logistic regression model. So I'm showing you the regression coefficients as well as the significance of each of the features. So the headline result and the two most important features appear to be the price that's being offered, as well as the percentage of positive feedback assigned to the merchant. So both models sort of agreed that these were highly correlated with selection for the buy box, and this was highly significant. And this sort of makes sense, right? Amazon is known for trying to offer low prices. It makes sense that the algorithm would try and choose a merchant offering a low price for the item. Taking feedback into account also sort of makes sense, right? Amazon also cares about customer service. If there's a merchant that is offering fast shipping, people are satisfied with the product, they're leaving good feedback, that's a signal that this merchant is reliable, and that should be taken into account as well. Now, one of the interesting things we saw is that the decision tree didn't think FBA, so fulfillment by Amazon, was important, but the logistic regression did. It saw it as highly significant. So this is sort of interesting. Merchants will tell you that using FBA is very important to get the buy box, and the logistic regression is agreeing with that. But the interesting thing is that all the merchants, more or less, offering low prices use FBA. So while it's highly correlated with selection, it doesn't actually offer a lot of discriminatory power, which is why the decision tree ended up not really caring about this feature. Now, the one other interesting feature that I'll point out here is something we added to the model that basically just asked, is the merchant that was selected for the buy box Amazon itself? Right, so this is a binary variable. Yes, it's Amazon, or no, it's not Amazon. So we actually saw that this did get some weight in the decision tree model, right? So it seems like maybe Amazon is being conferred some advantage here within their own market. If you just look at the data that we collected, we saw that if Amazon offered a given product, they were selected for the buy box around 90% of the time or more. So if Amazon is there on a product, they are highly likely to be in the buy box. So this raises an interesting question. Is Amazon putting their thumb on the scale and essentially giving themselves an advantage with respect to the buy box? We can't say one way or the other. It could be that that's true, although I don't actually think that's the case. Instead, what I suspect is happening here is that there are unobserved variables that matter. So for example, things like the speed at which you accept returns or the speed at which you answer queries from customers may matter. Those are variables that Amazon could observe and put into the model, and they would play into kind of your customer or feedback reputation. But we can't observe those variables. So it's entirely possible that Amazon scores very highly on those characteristics, which appear to give them an advantage. But we can't unpack it because we can't see the variables directly. We only have this kind of meta variable. So let's move on to talking about dynamic pricing. So this was the original goal of the study. We wanted to understand whether merchants on the platform were engaging in dynamic pricing. So to try and detect this, we're going to rely on a key assumption And this is that dynamic sellers, if they're engaged in this practice, are going to try and peg their price to some other seller's offered price over time. So we looked at several different targets for pegging. You could peg to the lowest offer price. You could peg to the second lowest offer price, which is important actually if you're always trying to be the lowest. Or you could peg to Amazon's price, if this is a product where Amazon offers it as well. So we looked at cases where the peg could be a fixed amount, right? So you could choose to peg to the lowest offer price plus or minus some fixed value, or this could be a percentage. So you could peg to, say, the lowest offer price, but go slightly above it or slightly below it by some percentage. So the approach we use to detect this kind of dynamic pegging is the following. We treat each seller's offered price for a given product as a time series. We then compute the target price time series corresponding to that product. So we have a number of different targets per product, lowest offer, Amazon's offer, and second lowest offer. We then compute Spearman's rank correlation between the time series. So this is the time series that was offered by a particular merchant. And then there's another time series corresponding to the potential peg, like lowest offer over time. And then finally, we assume that sellers are engaged in dynamic pricing if the correlation is greater than or equal to 0.7 and the p-value is less than or equal to 0.05. So relatively high significance. So in total, in our data set, based on this criteria, we saw 543 sellers who are pretty clearly engaged in dynamic pricing. So we call them algorithmic sellers in our paper. These merchants were offering 513 unique products. So to put that in perspective, our data set had thousands of merchants in it. So the relative fraction who appear to be engaging in dynamic pricing is pretty small. But also keep in mind that we only looked at 1,000 total products. So over half of them had at least one merchant engaged in dynamic pricing. So here's some examples of the behavior we saw. So these are time series. We have time on the x-axis, and we have the price of the product on the y-axis. In both examples, the red line corresponds to a merchant that was engaged in dynamic pricing. The other lines corresponds to other merchants. So in both cases, what you can see is that the seller engaged in dynamic pricing is hewing very closely to the offer prices of the other merchants. The other merchants are coming and going, right? So they, like in the top left, there's a green merchant who disappears, right? They're replaced by a purple merchant, but that red merchant is always just below their offer price. Here's two other examples. And in these cases, the dynamic pricing, again, the red line, is actually Amazon itself, right? So this is Amazon offering the product. And instead of actually pegging to the lowest price, what we see is that Amazon is pegged to a price that's slightly higher than the other merchants. This is especially apparent in the plot on the bottom left. You can see that the price of this product is highly dynamic. It's fluctuating over time. The merchants are coming and going, but Amazon is always slightly higher than whoever is offering the other price. So I can give you some high-level facts about the sellers that we saw engaged in dynamic pricing. In our sample, they sell fewer products overall than the non-algorithmic sellers. So they have a smaller range of things that they offer, but those things that they offer tend to be available for longer periods of time than other sellers. So this suggests that these sellers are highly committed to these products. They have larger inventory of them, and they sell them for longer periods of time. The sellers engaged in dynamic pricing tend to have slightly more positive feedback than non-algorithmic sellers, right? So in terms of the star rating, their star ratings, the average star ratings are a little bit higher, but they also tend to have a lot more total feedback. Now, this is really important because this suggests that they're selling a lot more items, right? The only way to accrue feedback is to actually sell things and then solicit feedback from customers. So if they have a lot more feedback, that suggests they're making a lot more sales. Now that makes sense given our next observation, which is that the sellers engaged in dynamic pricing are much more likely to secure the buy box than the sellers who are not engaged in dynamic pricing. Right, so the sellers who are engaged in dynamic pricing have an advantage here. Right, they're likely to secure the buy box, which means they're likely to make more sales. That results in them getting a lot more feedback, which then confers advantage in the future with respect to the buy box algorithm. So here's a couple of more observations we made. So the plot on the left is showing the change in price for a product where the seller is engaged in dynamic pricing versus the sort of baseline. So this fluctuates from negative numbers to positive numbers, where negative would be the algorithmic seller is pegged to a price that's slightly below everyone else, and positive numbers indicate that they're pegged to a price that's slightly higher than everyone else. So the interesting thing is that the bulk of density is actually to the right of zero, meaning that when people are engaged in dynamic pricing, they tend to peg to a value that's slightly higher than everyone else. Now, some of this is Amazon itself, and it's pretty clear that Amazon, when they offer a product, can actually, their offers are slightly more expensive than competitors, and yet they still get the buy box. But this is also true even for third-party merchants. And part of this is explained by Amazon's fee structure, right? So if you sell products on Amazon, there's typically around a 15% cut of sales that you have to pay to Amazon as a fee. And that can go up if you're also using FBA. So it actually makes sense if you're engaged in dynamic pricing and you're using FBA, you may have higher marginal costs than other sellers. So you have to peg to an amount that's slightly higher. So the plot on the right is showing the number of changes that we observed in the buy box over time. And we're splitting out now cases where products did have an algorithmic seller and cases where a given product did not have an algorithmic seller. So the blue lines are products where there was no one engaged in dynamic pricing. And the red line is cases where there was someone engaged in dynamic pricing. So what we see is, again, a very clear sort of stratification here, where the products that had someone engaged in dynamic pricing had a lot more dynamics in the buy box, both in terms of price as well as the merchant. And again, this sort of makes sense. When there's at least one merchant engaged in dynamic pricing, there's going to be a lot more changes to the underlying data in terms of the offer prices. So we would expect the occupancy of the buy box to fluctuate. So a couple of takeaways. As I mentioned earlier, this is one of the first studies to try and look at kind of the dynamics in Amazon Marketplace and how the mechanisms are structured using an empirical lens. We use regression and machine learning to try and investigate the buy box. We saw some things that we expected, like price and feedback and membership in FBA being important. But this also leads to some interesting consequences. You would assume that Amazon would always try and highlight the lowest prices for given products, and this is not true. Sellers that have a lot of feedback are conferred an advantage because of the structure of the algorithm, and that means they can actually sell things at higher prices, but still capture the buy box and thus capture the majority of sales. Finally, we present this kind of time series analysis looking at how merchants engage in dynamic pricing. Again, as of 2016, the majority of merchants were not engaged in this, but they have an outsized influence on kind of the dynamics of the marketplace overall. They tend to be the ones who capture the buy box. Price exploration by the algorithms drives a lot of the dynamics. And so basically, this is causing the marketplace to fluctuate. So a couple of higher level points. I would argue that algorithmic opacity is bad. And this is something that very much motivates my work and why I try to dig into how these systems work. It's unclear whether Amazon is giving themselves an advantage in their own marketplace with respect to the design of the buy box algorithm. Right? We have some tantalizing evidence that maybe that's true, but maybe it's not. We don't really know because the algorithm itself is still opaque. But this is concerning. So I would argue that dynamic pricing is adversarial to consumers. If you think about purchasing airline tickets or hotels online, people often describe the experience as stressful, right? These are areas where it's known that there's a lot of dynamic pricing, and people always feel like they're getting screwed because they never feel like they're getting a good deal. They always, have regret that prices will go down. As we move into a world where this kind of high frequency dynamic pricing is done across all retail, that really imports those kinds of anxieties into scenarios where people don't traditionally have them, right? The idea that you can walk into a store and prices are relatively stable just isn't true on something like Amazon, where there's this high frequency dynamic pricing going on. I would argue that there are some pernicious consequences to the design of the buy box because it is a winner-take-all algorithm. It's pretty clear, what we see is that, sellers will do things like reduce their prices in order to capture the buy box. They'll keep their prices low in order to accrue feedback. Once they accrue sufficient feedback, that actually enables them to start raising their prices above competitors, and yet still capture the buy box and thus capture the majority of sales. So you couple this with the design of the website itself, which discourages price exploration, and you have a situation where a powerful incumbent like Amazon itself can essentially capture all sales of a product. By design, people on Amazon purchase things through the buy box. Very rarely do they go and click that little link and look at the other offers. So the idea that people are always paying the lowest prices on Amazon just isn't true. The other thing to think about here is that the design of this system does appear to result in unintentional algorithmic collusion. I showed these time series plots of the price movements of products over time, and it's very clear that there's a lot of correlation going on. So there's very obvious cases where one seller will start to explore prices going up or down, but other sellers are pegged to them, and they'll move up or down in tandem. So again, I'm not suggesting that this is intentional collusion, but the effect is that all prices move in tandem in the same direction, and it's not driving all prices to lower to benefit consumers. This is often driving prices upward, which again, this is probably not great. So that's it. Thank you for listening in, and have a good time at the rest of the workshop.
Thank you very much for this again. So I'm gonna partly abuse my position as a sole live audience, and just a few quick clarifying questions. One is, as I understand, to maintain dynamic pricing on Amazon or algorithmic pricing, you don't really need to even know how to code, right? So part of it is a feature of the platform itself. It's not like you're running a Python server with an API somewhere, right? And relatedly, the things that you mentioned, the pegs that you can peg to the second price, the Amazon's price, and so on, those are the features of this platform as well, right? These are, or right? Okay, so these are the things that I can literally peg to.
Yeah, so my understanding of the Amazon seller interface is that it does offer some dynamic pricing capabilities to everyone who's part of the platform, and those capabilities are relatively unsophisticated, like these kind of sort of obvious pegging strategies. There are also third-party platforms that cater to Amazon merchants. So they try and help you manage your inventory on Amazon, manage like queries from customers, and they will also enable you to do dynamic pricing. And they provide kind of this menu of options. You can choose different pegs, you can choose different amounts, you can set reserve prices or ceiling prices. And like you said, those are no coding necessary. They're really designed for mom and pop shop who just want to sell on Amazon. There are now more sophisticated versions of those third-party platforms that claim to use machine learning. So they'll be looking at all the other offer prices and trying to do very, or at least they claim to be using very sophisticated techniques to figure out what your price should be to make sure you get the buy box. at some point I would love to audit one of those and see actually how that works. And then of course there's the actual underlying APIs. So if you can program, you can hook up to Amazon's API and engage in kind of whatever pricing you want. Because at that point you just have raw data and you can send them new prices as often as you want.
Right, so that actually segues into my second question, which is somewhat less fair. So do you see any evidence for some more complicated strategies than, say, pegging to other prices? Like, I'm leading to this kind of literature that you mentioned on algorithmic collusion and unintentional algorithmic collusion. So is there evidence of something like reinforcement learning or some exploration and that kind of strategy? I know it's not fair because I don't even have immediately an idea how would you detect that in the data, but
yeah, I mean, I don't think we can say one way or the other, just based on these kind of very simple correlation models we were using. I don't think we would be able to pick up on really sophisticated behavior. But that said, just Googling around for merchant services for Amazon, there are these startups who claim to be using it and offering it as a platform for merchants. So it seems like it's at least possible that there's people using neural networks or reinforcement learning or more sophisticated models. But the actual kind of practical impact of them or the strategies they end up adopting are unclear.
And the very last question. Thank you for answering all of those. The methods that you use for this, right? The crawling of Amazon's website, and in other places you also use custom Chrome extensions, and all of this is almost like a sort of forensic work on detecting on reverse engineering the algorithms. And as I understand, the reason is that the algorithms are opaque and closed source. So is there and perhaps obvious reason for why the algorithms are often closed source, in particular the buy box? Because Amazon seems to mention the features that may be important for the sellers and how to win the buy box and offer, but not the algorithms itself. So I guess it's for commercial reasons, which would be an obvious reason, but yeah.
Yeah, and I think the obvious one is they claim that this is PI, so it's all proprietary and they don't want a competitor to know how the thing works. I think the other big reason is that they'll claim that this is a security feature. So they don't want a seller to learn about the secret sauce and then game the algorithm for some unfair advantage. I personally don't subscribe to that. So I have a cybersecurity background, and we call this security through obscurity. The idea that the algorithm is secret and therefore secure, and we know this is a fallacy. So it's not just me who's trying to reverse engineer this. There's a whole cottage industry of merchants and people catering their services to merchants who are also trying to reverse engineer this because there's an advantage in doing so. There's blogs that talk about changes to Amazon's algorithms and what it's going to mean for your business. So there's all kinds of people trying to reverse engineer this. I come at it from the opposite perspective, which is that I think it should be transparent because that levels the playing field. Now we know how it works and we can compete accordingly. If there's some way for a person to game the algorithm, the idea shouldn't be that we like hide the flaw. The idea is that you should go and fix the mechanisms so that the flaw isn't there anymore. But I'm clearly in the minority on this because, again, most of these platforms are very opaque.
But the parallel with cybersecurity and ciphers makes a lot of sense. Right. Thank you so much. I think we will stop here, but thanks again for a fascinating talk.
Yeah, happy to. Thanks, everybody.